Hello, we are Alliance Road Construction, and I would like to present to you our project. Let's start with the team. Our team consists of management and design specialists. Nanuka Komareli as quantity surveyor, Ani Kantaria and David Kurgenidze as CAD specialists, and Nina Chkhartishvili as traffic analyst. And of course, me as the project manager. Our project aimed to create the design for E-60 highway Samtredia-Grigoleti road section. The project's focus is the interchange, which provides an overpass bridge that must be connected to the main motorway with access ramps. This project has given the highest priority for the promotion of trade with the neighboring countries and the development of tourism infrastructures. The following key disciplines were covered within this project: basis of design, traffic, drainage, soil, hydrological studies, environmental assessment, cost estimation, planning and scheduling. Moreover, the scope included developing schedule for construction, bill of quantities, and suggesting work execution approaches. Key dimensions presented in the design are as follows: main road 1.2 kilometers, ramp 1 370 meters, ramp 2 375 meters, ramp 3 355 meters, ramp 4 385 meters, and 2 roundabouts with a radius of 30 meters. As a first step, we developed the schedule to track the progress of our own work and RESI metrics to define the areas of specialties. We developed WBS and used visual task boards to manage deliverables.
Thank you, Mariam. So our team conducted site visit to have the better understanding about the design requirements and approaches. As a result, we have successfully delivered the preliminary and full design packages. In order to maintain focus on status of deliverables, we held weekly meetings and discussed works in progress as well as upcoming tasks. I have prepared BOQ, used SNPs part 4 for roads, and as it is governmental project, I used prices of construction resources as a reference, which gives predefined values and approved by the Georgian government. To prepare the BOQ, I have used CAD to collect information about required amounts of materials and used Excel while processing this information and developing the final document. As you can see, BOQ will have groundworks for main roads, ramps, and roundabouts. For the base and sub-base layers, we have 2 different types of materials with different quantities, which is reflected in our document. As for asphalt layer, we have 2 layers for main roads and ramps and 3 layers for roundabouts. The cost estimation includes road signage, marking prices, and all the required elements for proper functioning of the highway. Considering all the materials required for this project and using suitable formulas, we have calculated the total cost. And to prepare the document, I regularly consulted with the design team, and now they will continue the presentation.
Thank you, Nanuka. Interchange that we designed is the second interchange on Samtredia-Grigoleti section of the 4-lane E-60 highway designed by Joe Group. This highway carries a huge importance for improving the east-west mobility between the Caspian and the Black Sea. It is divided into 4 lots, and the ramp that we are designing is located on the lot 1 between 6 and 7 kilometers. The requirement from the contractor was to design a diamond-type junction with roundabouts on the both sides of the highway. A diamond interchange consists of 4 ramps that enter and exit the freeway at minor angles and meet the non-freeway at almost straight angles. Diamond interchanges are substantially more cost-effective in terms of material and the land utilization than other interchange designs because a junction usually requires only 1 bridge to be built. However, the capacity is smaller than that of other interchanges, and they can rapidly get crowded when traffic numbers are high, which we made sure would not be the case in our design, as it is a service interchange that mainly serves as a turning point for the vehicles traveling on the highway. As requested by our team, the contractor provided topographic, traffic, geological, and hydrological data. Contractor provided the working division file of the main road sections that were used to gain the necessary parameters of the main road alignment. For drafting the alignments of the ramps, we also had to consider the elevations of piers of the overpass. We requested that data as well, as the overpass wasn't included into our scope of works. Now, Annie will continue with other details of the design.
Thank you, David. Overall, the scope of works for the design team included the following: geometric design of 4 ramps and 2 roundabouts, pavement design, vertical and horizontal markings of the road, drainage, and delivering plans, longitudinal and cross-sectional views of all elements mentioned above, as well as some detailed drawings. Calculations for the pavement design was done in software Robur. Main portion of the road geometry was done in software Civil 3D and AutoCAD. As mentioned earlier, the different alignments were discussed with mentors and contractor. 2 alignments were considered, drafted, and calculated by our team, and the best of those 2 were selected. The first type of ramp alignment consisted of two horizontal curves on each ramp of length 400 meters. It occupied a total of 95,000 square meters and had a roundabout with radius of 16 meters. The second alignment had just 1 horizontal curve, 350-meter long acceleration and 380-meter long deceleration ramps, roundabout radius of 30 meters, and occupied about 90,000 square meters. Other parameters of these 2 alignments were roughly the same. The group chose the second alignment over the first, as it proved to not only be more cost efficient, but also improve the mobility and the safety as well. The ramps were designed by the same standards that were used for the main highway. The width of the carriageway for the ramps is 4 meters, and for the roundabouts, it's 8 meters. Cross-sectional slope is 20 promiles, and the vertical slope from roundabout to highway is less than 10 promiles. These geometric parameters were used consistently on all 4 ramps and were carefully chosen based on the design standards, SNPs, and Georgian state standards, SST-XEPI. Now my friend Nina will continue with the traffic study.
Thank you, Annie. For comprehensively analyzing the road capacity and correspondingly choosing design criteria, the traffic analysis was conducted. The gathered data prior to our project and provided by the contractor played a vital role in this aspect. The classification of counts and determining origin-destination surveys on 2 different sites gave the opportunity to predict the future traffic projections and consider the standards of the American Association of State Highways and Transportation Officials. Correspondingly, design speed and site distance were calculated for maximizing the optimized final road design. It is substantial that the design speed for the deceleration lane is 30 km per hour, while for accelerating lane is 50 km per hour for our ramp design. Moreover, minimum required acceleration site distance was 77.8, while in our design, we had 180 meters. Whereas for deceleration site distance, minimum required value was 49.8 meters, and we have 100 meters. In the concluding stage, after having the completed base drawing, both horizontal and vertical signage were also delivered. Now let's talk about pavement. The pavement of the roadway on the presented facility was calculated in accordance with the requirements of the current normative document, ODN. Traffic intensity was obtained by estimating traffic flows based on actual traffic conditions and the prospective development zone factor. The pavement was calculated for 4 main deliverables, and they are flexible bending, movement resistance, static load, and bending deformation. The service life of the pavement was set at 20 years, considering the planned maintenance work as well. As a result of the calculation, there are 2 different road pavement prepared. Option 1 includes the construction of road pavement to be arranged within the ramp, and the second option is the construction of road pavement to be arranged on roundabouts located within the traffic junction. Depending on the intensity of the traffic, the required modulus of elasticity within the ramp is 271 megapascals, and within the roundabouts, it is 264 megapascals. Based on calculation results, the actual modulus of elasticity of the pavement according to option 1 is 298 megapascals, while in the case of roundabouts, it is 297 megapascals. Established on the results, we can say that the condition is satisfied by the stock coefficient.
This is the end of our capstone project presentation, and we would like to thank you for your time and attention.